Hello, geometry. Today, we're going to talk about 7.3, similar triangles. I'm Mrs. Applegarth. It's such a pleasure to hang with you. We're going to start out taking a look at the example. We know that triangle ABC is similar. Remember, this little tilde sign means similar to DEF. And we need to find all the missing angles. So we are going to use that triangle sum theorem. And I just loathe the nice, I want a nice thin line. Triangle sum theorem says that all angles add to 180 degrees. So we know that A goes with D. So the angle that we have for A is going to be for D as well. Okay, and we know that E goes with B. So E is 90 degrees, so B has to be 90 degrees. And then C goes with F. F is 51 degrees, so this one also has to be 51 degrees. And now we have all of our missing angles. Yay! All right. Angle, similarity, postulate. Angle, similarity, postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all we have to do is prove that two angles are congruent, and then we can call these guys similar. So for example, S is congruent to M, R is congruent to L. We know because of the triangle sum theorem that T is congruent to P, so we don't need to claim that out. We just need the two angles. And then we can say that the triangles are similar. We know that similar triangles or similar anythings have the same angles and their sides are proportional. Okay, so let's take a look at example 2. We want to know, we want to determine whether we can prove the triangles are similar. So you guys take a moment when you're taking your notes, go ahead and draw the pictures. Drawing the pictures will engage a piece of your brain that'll help you remember. Some of you guys don't want to draw the pictures, and doggone it, drawing is the most fun that we have in class. So we're going to draw this like big triangle here. So draw W, Z, Y, and go ahead and label it W, Z, Y. And then take that about midway between W and Z and throw in a line. And now we have, and label that V and X. So now we have our triangle. We know that V and Z are 90-degree angles. And we can say that W, V, X and W, Z, Y. So you guys, the little guy on the top and the big triangle WZY is this big guy. Woohoo! The big guy. Are congruent. Well, they're not actually not congruent. So let's hide that real quick. So they're similar. There we go. WVX and WZY are similar because all right angles are congruent, and W, check out this little guy on the top, W, they share W. Boop, 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 boop. So because they share W, W is congruent to angle W by the reflexive property. So WVX is similar to WZY. All right, let's look at this crazy little, like, it's two little hills, and we got some parallel lines going on. So it's difficult to see parallel lines, so let's make these look a little bit more like parallel lines. So this one, this guy shoots out here, and this guy shoots out here, and they're parallel to each other. So the greens are parallel, and then this guy, getting kind of sideways on my drawing. So this guy shoots out here and this guy shoots here, and they are also parallel. So the beautiful thing about parallel lines is alternate interior angles are congruent and corresponding angles are also congruent. So we're going to check out from the green. I ran off my board. Okay, so this angle underneath the green and this angle underneath the green are congruent because they're corresponding angles. Okay, sorry, I had to take a moment and clean up my lines. Okay, so we're going to use this line as our transversal. And then if you look, the blue lines cross the blue parallel lines cross the transversal, and the angle to the left of where it crosses the red line are, or this bottom line, are corresponding. And then we do the same thing with the green, where or the ones, these lines right here. So the lines where it touches this bottom line, they are going to be congruent because they're corresponding angles. And if we have two angles, we know that the triangles are similar. Okay. Example 3, we are going to solve for the missing side of the following triangles. I think of a triangle because it's got 3 sides. So in a triangle, usually we have a long side, a medium side, and a short side. I'm going to be abbreviating them as long, medium, and short. So, and that helps me group the things together that belong together. So I'm looking at this triangle right here. First, we need to establish if they're similar. They both have a right angle, so those are congruent. And these are vertical angles. Remember, let's make that look like a V. Vertical angles are congruent. So by angle similarity, we know that these two triangles are similar. So this is the long side. Any side across from the 90-degree angle is going to be the long side. So we can match those up in our proportion together. So we can go 20/15. And then we're going to go x. X is the short side. We're going to match this up with the short side. And I know you're like, Miss Alvarez, this is so easy. Like, stop. Like, I know I can see that's short. Why do I have to write it? Because when we get to the more difficult subject in 7-4, it's important to keep track of what we're hunting for. We have the option, we can reduce 20/15. So I'm going to divide both of those by 5, and it's actually 4/3. So we're going to go 4 times 6 is 24 equals 3x, and then divide by 3. And x is equal to 8. Yay! Okay, let's look at B. B has 65 here in the corner, 65 here in the corner, and it's got vertical angles that are also congruent. So 2 angles means that my vertical angles, that means I have similar triangles. So we are going to go, okay, this is the long side. How do I know that it's the long side? It's 48. This is the medium side, which is 45 is less than 48. And this has got to be the short side because 35 is shorter than both 48 and 45. This guy right here, we call this, so the one across from the vertical angle is the short side. So it's got to be the same over here. This has to be the short side. The one across from the 65 is the medium side. So this also has to be the medium. So I'm going to use medium and short because I only have medium and short on this triangle here. So I'm going to go x over 25, and that's the medium and the short. And then I'm going to pull the medium here, 45. over 35. Doesn't matter which one's on top. If you put the short on top, then the short has to go on top on this other side as well. We can reduce 45 over 35 by dividing by 5. 45 divided by 5 is 9. 35 divided by 5 is 7. So I'm going to go cross multiply. 7x equals 9 times 25, which is 225. And then we divide both sides by 7. And we get 32.1. And I'm going to change my equals to a squiggle because I'm going to round. And that would be centimeters. Okie dokie. On to our next theorems. Theorem 7.2 is our side angle side similarity theorem. Okay, pretty similar to what we did in our previous chapters. So let's write this down. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional. So remember, we're similar triangles, we're not congruent triangles, so the sides have to be proportional. So you need one angle, and then the the lengths of the sides that include the angles as proportional. Then the triangles are similar. So one angle, sides that include the angles are proportional. Okay, side similarity says if the corresponding sides of two triangles, so that's all of the sides, are proportional, then you can call out that the triangles are similar. All right, so let's take a look in example 4 of some scenarios. So we have determine which of the following triangles are similar. So we're going to take a look at A, B, C and compare it to D, E, F. So we go short side, medium side, long side. What is the short side of DEF? Oh, it's 4. So we're going to buddy 6 up with 4. The medium side for our first triangle is 9. So we're going to buddy that up with the medium side of DEF, which is 6. And then the long side of ABC is 12, and the long side of DEF is 8. So now we have to simplify each of these proportions. So we get 3 halves, 3 halves, and 3 halves. All because side, all sides are proportional, we can say ABC is similar to triangle FED by side. All right, so let's compare our middle triangle to this guy over here. So we're going to go short side and short side. The short side is 6. Short side here is 4. Okay, let me change that. Sorry, that was incorrect. So short side, oh, actually, 6, 7, 12. Okay, so we're going to compare the short side of, so we're going to go DEF to GHJ. So these two triangles we're going to compare. So we're going to go short side here, which is 4, over short side here, which is 6. Is it going to be equal to the medium sides, which is 6 over 10? And is it going to be equal to the long sides, which is 8 over 14? Okay, we're going to reduce all these down. This gets reduced to 2/3, or sorry, 2/3. This gets reduced to I'm going to put a question mark because we don't know if it's equal yet. This gets reduced to 3/5, and this gets reduced to 4/7. None of them are equal. No. So the second two triangles are not similar. And we can compare. Let's go ahead and just out of funness, let's compare. So I'm going to compare our first triangle ABC to H, E, F, G, H, I, J, H, G, J to our ABC. And so let's go small, medium, large, and we'll compare it to small, medium, large. And this, we're going to reduce this down. I already know not going to be equal. So this is 1 over 1 is not equal to 9/10, which is not equal to 6/7 either. So what we have learned is that the first two are similar. Okay. Example 5, are the triangles similar? If so, what postulate or theorem would you use to justify your answer? So check out, we've got this triangle here, the very tippy top, and then we've got the big guy. We're comparing those two triangles. So we can say that angle S is congruent to itself, and that's the reflexive property. And then we need to compare the sides. If they are proportional, then by side angle side, we can say that they are similar. So we're going to compare 4 to our complete side. So it's not just 12, it's 4 plus 12, which is 16. And we're going to compare that to 5 over, not just 15, but 5 plus 15, which is 20. So that 4 over 16 reduces to 1/4. 5 over 20 reduces to 1/4. We can see that those are equal. So they are similar by side angle side. This guy right here, we need to see if their two angles are equal. We can see that this angle is 72, this angle is 72. I have a little quandary here. This is 41 and this is 67. So we need to find our missing angles here to see if any of them match up. Is this one 41? Is this one 67? So that's just a quick calculator. We've got 67 plus 72 is 139, and we subtract that from 180, and it is 41. Yay. Okay, so then we can say triangle ABC is congruent to triangle FDE by angle. Is similar. ABC is similar to triangle FDE. Okie dokie, artichoke. Now it's the practice problems. Pause. I'm going to scroll slowly. Pause and get each one that you need. All right, and that's our lesson for today.